Okay, now we're ready to factor trinomial, which is a three-term polynomial. And so I'm going to introduce to you the AC method. There are other great factoring methods out there, better than this even, but this is a pretty great one if you don't already have one. So what you do when you have a trinomial, which means a three-term polynomial, this is based off of ax squared plus bx plus c. You would take the coefficient of the first term, a, and multiply it by the constant term, a times c, and you want to find two things that you can multiply together to get the number a times c, but that will add up to be b. So this is our goal. So if we look at number 5, it is m squared minus 5m minus 14. So the coefficient a in this case is a 1, and c in this case is negative 14. So a times c would be negative 14. We want to find two factors of negative 14, two things to multiply together to get negative 14 that add up to be a negative 5. So if you multiply two things and get a negative, the only way that can happen is one is positive and one is negative. So one of the factors positive, one is negative. What times what gives you 14? What comes to my mind is 7 times the 2. So 7 times negative 2 gives me negative 14. And 7 plus negative 2 gives me positive 5. So that's close, but that's not right. I need a negative 5. So if you just switch the signs here and make this negative 7 times positive 2, that gives you negative 14. And when you add these two things together, you get negative 5. When the leading coefficient, a, when a is 1, you can go ahead and factor this into m minus 7 times m plus 2. Let's go again. The a times c for number 6 would be a 1 times a negative 5. We want two things to multiply together to be b, which is 4. If you multiply something and get a negative, it's got to be a negative times a positive, so one is negative and one is positive. 1 and 5 come to mind. And if I want a positive 4, the bigger number needs to be positive. So negative 1 times 5 is negative 4. Negative 1 plus 5 is 4. These are the winning numbers. So x plus minus 1 times x plus 5 is the correct factorization. Now, if you factored this and you wrote down x plus 5 times x minus 1, that's exactly the same thing, and that doesn't matter. That's just fine. That's called commutative for multiplication. That's allowed. All right, let's do 7. A is 1, c is 20. 1 times 20 is 20. We want two things that would add up to be 9. 4 times 5 is 20. 4 plus 5 is 9. So z plus 4 times z plus 5. Okay. A is 1, c is 7. 1 times 7 is 7. I want two things to add up to be negative 8. Okay, if it's a positive number, that can happen by multiplying a positive times a positive or a negative times a negative. In this case, it's going to be a negative times a negative because we want two things to add up to be negative 8. So a negative 8 times a negative 1. Oh, that's not working. Sorry. Let me try again. Negative 7 times a negative 1 gives us a positive 7, and a negative 7 plus a negative 1 is negative 8. So this last one factors into b minus 7 times b minus 1. Okay, here are two problems I wanted to do where the leading coefficient is not 1. So if the leading coefficient is 6 as opposed to 1, or 12 as opposed to 1, and you have a trinomial that will factor, this is an extra step you have to do in this method. You say, what is A? It is 6. What is C? It is negative 12. So A times C would be 6 times negative 12, which is negative 72. And then what is B? It's negative 1. So I want to find two things, multiply together to get negative 72, but add to get negative 1. One thing's positive, one thing's negative to get a negative number. Let's see, 8 times 9 gives me negative 72. 8 minus 9 gives me negative 1. Okay, these are the winning numbers, but I cannot directly factor. I have to rewrite, so I'm factoring 6c squared minus c minus 12. I have to rewrite the middle term, negative c, into 8c minus 9c. 8c minus 9c is the same thing as negative c. The order that you write these down does not even matter. I'm going to write it down plus 8c minus 9c minus 12. However, if I had selected to write this down as 6c squared minus 9c plus 8c minus 12, this will still factor correctly. Once you've written and you have 4 terms, you group the first 2 terms together and the second 2 terms together. Then you factor out the greatest common factor that you can find from these 2 guys. The biggest thing I can pull out is a 2 times a c. And that leaves me with the 3c plus 4. And if you're not sure if that's right, just multiply back together to make sure. Now, here, if there's a negative right here, you must factor out the negative plus anything else you can. So a 3 will both go into these. So I'm going to factor out a negative 3. When you factor out a negative, it has the effect of changing the sign of what's left. So I'm left with a positive 3c and a positive 4. This is not coincidence. This is factoring. These 2 terms will be the same. I have a match. So I'm going to factor out that match, 3c plus 4. And then what's left is this 2c minus 3. This is the correct factorization. I'm going to do that one more time. If I have 12x squared plus 7x plus 1, it is 12, c is 1. 12 times 1 is 12. I want 2 things I can multiply to get 12 and add to get 7. 3 times 4 is 12. 3 plus 4 is 7. These are good numbers. What I'm going to do is rewrite the middle term, plus 3x plus 4x plus 1. I group the first 2 terms and the last 2 terms. The greatest common factor I can pull out from here is a 3x, leaving me with the 4x plus a 1. There's no common factor here. But I realize that what's in front of this whole thing is a 1. So I factor out the 4x plus 1, and I'm left with a 3x plus 1. This is the AC method for factoring trinomials. Now, factoring binomials. These are largely based off of knowing the special factorizations right here. So the difference of 2 squares right here is x squared minus y squared factors into x plus y times x minus y. X plus y quantity squared, we talked about this when we multiplied. This is the same thing as x squared plus 2xy plus y squared. Now, this is also a trinomial, so I don't ever look at a formula to do this. I just use the AC method, and that I get x plus y times x plus y, and I realize that's x plus y squared. This is the difference of 2 things cubed, and this is the sum of 2 things cubed. Today, I'm just going to be looking at squares. So right here, we have a binomial, a 2-term. 21 is x squared minus 64. I recognize that this is the same thing as x squared minus 8 squared. So this is a squared minus b squared, or x squared minus y squared, which by formula factors into the first thing plus the second thing times the first thing minus the second thing. This is difference of squares. I recognize that this was the subtraction, the difference of 2 things being squared. Okay, let me go at 23. I have 10x squared minus 160. Nothing is really fitting a pattern, but I can factor out first the 10, leaving me with x squared minus 16. So by factoring out that greatest common factor, I recognize now that I have the difference of 2 things being squared. This will factor into 10 times x plus 4 times x minus 4. This is the difference of squares. Let's look at 22. 9m squared minus 25. Can I take the square root of the first thing? Yeah, it's 3m, so I have something squared. Can I take the square root of the last thing? Yes, it would be 5, and there's a minus in the middle. So this is also difference of squares. This is 3m plus 5 times 3m minus 5. And that's how we would factor that. The last one, 24, is 9x squared plus 64. So it is true, we can take the square root of 9x squared, it would be 3x, and we can take the square root of 64, it would be 8. But we have a plus, we don't have a minus, and we do not have the sum of squares. There's no formula for that. This does not factor, and so when something doesn't factor, we call it prime, meaning we cannot break it down any further into factorizations. So that is factoring.